If a plastic rod is rubbed with fur, the rod obviously will gain a negative charge. Now you're going to touch the two small pit balls with it. The negative charge will, if you touch it, it will get transferred to the balls, and both the balls will get negative charge, will get repelled, and option number B with equal and opposite force. That's the right answer. Let's go to the next question. A comb runs through one's hair, one's dry hair. It develops charges, and then you place it near the bits of paper. They attract by, because the paper is a polar dielectric medium, so the paper gets polarized, and opposite charge gets developed at the near end, and therefore the comb is able to attract the pieces of paper. Let's go to the next question. So then option number C is the right answer. So the third question, when one metallic sphere A is given a positive charge, whereas another is given a negative charge, both of them have the same mass. A and B have the same mass, one is given positive and the other is negative. Obviously, the one which is given a negative charge means it's gained an electron. Gaining of electron always increases the mass by a very small amount, the mass of one electron being 9.1 in 10 to the power minus 31 kg. But when it is given a positive charge, it actually means it's lost an electron. So then the one which is gained an electron always have a greater mass, and so B gains the mass and mass of B increases, so D is the right answer. Next, fourth, in nature, the electric charge of any system is always equal to option number D, integral multiple of the least amount of charge, which is known as quantization of charge. Sum number B. Sum number 5, the charge of one of the body is 1 nanocoulomb. Number of electrons, again quantization of charge, N is equal to Q by E. Q is 1 into 10 to the power minus 9 coulomb by 1.6 in 10 to the power minus 19 Q by E. That will give you 6.25 into 10 to the power 9. So then the option number B is right answer. So then next is sixth question. A charge on the body is Q1 and it is used to charge another body by induction. The charge on the second body Q2. You know that when a charge body Q1 is responsible for induction, the Q2 will gain a charge which is equal or lesser than Q1. So Q1 is greater than Q2, so Q1 by Q2 can be greater than or equal to 1. Greater than or equal. It can induce equal charge or lesser than it. Okay. So let's go to seventh question. Seventh question is which is the right graph? The force of attraction between two charges is inversely proportional to r square. So then option number C is the right answer. Eighth question. The unit of electric permeability is per Newton per meter square coulomb square. So option number A is the right answer. So the next question is Q1 is 6 microcoulomb, Q2 is 2 microcoulomb. Initial force between them is 12 newtons. Okay. Now, if you're going to, if charge Q is equal to minus 2 microcoulomb is added to Q1 and Q2. The net charge on Q1 will be 6 minus 2, 4. The net charge on Q2 will be 2 minus 2, 0. And the new force will therefore become 0 because one of the charges itself becomes 0. So option number B is the right answer. So let's go to the next question. A charge Q is placed at the center of two charges, capital Q and capital Q. The entire system has to be in equilibrium. You all know it has to be negative charge and its magnitude is to be minus Q by 4. We have dealt with this question before. So that's the answer, option number B. 11th question. 2 point charges A and B having plus Q and minus Q respectively are placed at a certain distance apart, and the force acting on them, let's call it as F. Now, at 25% of the charge from A is transferred to B, then the force between them, okay, you know both the charges are initially Q only, but one is positive, other is negative, so it is negative force, the force of attraction, which is minus K into Q square by R square. That's initial force. Now, the first body is going to lose 25% of its charge, so what's remaining is 75 by Q is what is remaining, 75 by 100 of Q, 75%. Is going to remain, so which is 3 by 4 of Q is what is left in the body A. The body B would have gained the 25% of the charge to 25 by 100, which is 1 by 4 of Q, which is the first charge, plus the charge on QB, which is already negative Q. So Q by 4 minus Q will be minus 3 by 4 Q, which will be minus 3 by 4 Q. Let me see. Oh shit, where is it? That has to be the, minus 3 by 4 Q. That has to be new charge on B. And the new force therefore is F dash, which exists between these two new charges. So F dash is equal to 9 by 16 of F. I should get this as the right answer. So 9 by 16 of F is A. Next, 12th question. If two particles of equal mass and charge are placed at a distance 16 centimeter, they do not experience any force. How is it possible? Then the Coulomb's force is being opposed by gravitational force of attraction. This is Coulomb's repulsion force equal to gravitational force of attraction, which is g m square by r square is equal to 1 by 4 pi epsilon q square by r square. Hence you can group r square get cancelled, you can group a q square by m square. From this cross multiplying you get q by m to be root of 4 pi epsilon naught to g, so D is the right answer. So let's go to the next question. 2 point charges placed at a certain distance r in air experience a force F. Then what will be the distance r at which the charges will exert the same force? The medium of dielectric constant K is inserted. You know, the initial force is Q1 1 by 4 pi epsilon Q1 Q2 by r square. The moment you place it in a dielectric medium, the denominator is epsilon naught has to be multiplied by a K, where the new force will come into play. And but he is saying the force is remaining, F dash is becoming equal to F. There's no change in the force, but the distance is adjusting. R dash is becoming new R dash whole square. So equate both of them, you get a relationship between R dash and R, and which is related to the dielectric constant K. So then that's the relationship. R by root K is the right answer. So option number C is the right answer. Let's go to 14th question. An object A has a charge of minus 2 microcoulomb and the object B has a charge of plus 6 microcoulomb. Which of the following is true? You know, one is negative charge, other is positive charge, and force is Q1 Q2 by R square. Either way, FAB and FBA will be equal and opposite. Therefore, the answer will be option number B. Okay, so 15th question is electric charges 1 microcoulomb, minus 1 microcoulomb and 2 microcoulomb are placed in the air, the corners of ABC on the equilateral triangle. Can you see the solution on the left side? The equilateral triangle side is 10 centimeter. So the resultant force on charge at C, the plus 1 and plus 2 will be repulsive. So and whereas the plus 2 microcoulomb and minus 1 microcoulomb, between them it will be attractive. You have to call this end as A and B, so you get FA and FB. Angle between them is 120. Are they of equal magnitude? One is between 1 and 2, another is also between 2 and minus 1, doesn't matter. So we can still call it as FA and FB because you don't have to take the negative charge into account. And the resultant will be just either of the F, which is 1 by 4 pi epsilon naught into 2 into 1 into 10 to the power minus 12, because both the 10 to the power minus 6 and minus 6 become 10 to the power minus 12 by the distance the whole square, 10 into 10 to the power minus 2 the whole square. We have discussed sums like this, so I'm sure it's pretty self-explanatory. So you don't have to do all this. We have a shortcut. We are not doing all this parallelogram law. It's F, and so the resultant between F and F, which angle 120 itself is F, and though you write the answer. So then let's go to 16th question. So it's so quick that you'll be able to solve. You wouldn't take so much time. Each corners A and C has charge Q1, and on the other corner B and D, diagonally opposite, has charge minus Q2 of the square ABCD of side length L. Okay. And the field strength at the point P. Point P, where is P? Oh no, I'm reading the wrong question. Okay. The charge at A is in equilibrium, then the ratio of Q1 by Q2. The charge at A is in equilibrium, the ratio of Q1 by Q2. Yeah, here I'm introducing you to a beautiful way. Can you see that the diagonal minus Q2 and minus Q2 is there? This diagonal Q1 and Q2 is there. The charge at A is in equilibrium. Just study the charge at A, the force at A is in equilibrium. Yeah. The net force at Q1 A has to be 0. So you know that the charge at D is negative, so it's going to be attracting it. Correct? And this minus Q2 here on the right side at the bottom is also going to be attracting it. And the Q1 is positive, this extreme diagonal is going to be repelling it. And so you get, it's been given that this forces FDA plus FAB plus FCA is equal to 0 for it to be in equilibrium. Okay, so then he He's resolved it, instead of resolving as vectors, he has done it so beautifully. You can also follow this way. So otherwise what would you do is, you will have this like this. Normally how would you do? This is Q2, this is Q1, this is Q1, this is minus Q2. Okay, if this has to be in equilibrium, this is going to be attracted by this is going to be attracted by this, and the resultant between these two is going to be in this direction. Okay, and this Q1 is going to be repelling this in this direction, and so basically the purple color and this has to get cancelled. Yes, and so then if this is L and this is L, I'll directly write this as root 2 L, and this itself is L. And let's write this force. The upward force is F is equal to K into resolved vector, so Q1 Q2 by L square, and this force is also F is equal to K into Q1 Q2 by L square, and this force, you know, the one that is between the diagonals is F is equal to, it's going to be repulsive in nature, sorry, it's going to be repulsive in nature, so it's F is equal to K into Q1 square by root 2L the whole square, which is 2L square. You know that if you're going to solve this, and this resultant will be in this direction. Okay, so then they are simply writing this as the resultant, you know, but both of them are same forces. So this angle will be 45 degree, 45 degree. So they're simply writing it as this into cos 45, and adjacent of this force is cos 45, and the adjacent of this force is also cos 45. So 2 times this cos 45, they just simply multiplying it like that, resolving it as components. Otherwise, you know, you have to do it as root of this square plus root of this square plus root of root of Q1 Q2 by yeah, so root of F square, and this is also F square, which is root 2 F, right? So which is root 2 F, therefore you know this is simply root 2 F, and that has to be equated with this to order to get cancelled. K Q1 square by 2L square is equal to root 2 into K Q1 Q2 by L square. L square get cancelled, K get cancelled, Q1 and one of the Q1 get cancelled. So you get Q1 is 2 root 2 Q2. Q1 is 2 root 2 Q2. Yeah, therefore Q1 by Q2 itself is 2 root 2. And this is the way I would do. I wouldn't resolve it as cos 45. We'll do it as normal 90 degree and find the resultant. I hope you understood. Okay, so then let's go to next. So let me discard this. And where is the PDF? Yeah. So you understood that part of the question, which is which question is this? Yeah, 2 root 2. B is the right answer. Let's go to 17th question. The force between two charges is 0.06 meters apart is 5 Newton. Okay, if each charge is moved towards each other by 0.04 meter, then the force between them will become. You know, force between two charges 0.606 meters apart is 5 Newton. If the charge is moved towards each other by 0, just so the distance is the force distance is reduced, moved towards each other, the force will only increase. So new force, you know, force is only inversely proportional to r square, because both the forces going to be proportional to q square and a 1 by 4 pi epsilon. The only factor is going to depend on is inversely proportional to r square. So the old force, which is phi, by the new force is equal to the new distance by the old distance the whole square. Therefore 0.04 by 0.06 the whole square. Hence you can calculate F2 to be 11.25. That should be the answer. So option number B is the right answer. So let's go to 18th question. When the charge of the body becomes half, the electric charge of the body becomes half, the electric field becomes the charge of the body becomes half, the electric field becomes E is equal to F by Q. No, E is equal to 1 by 4 pi, we should not take that, I'm sorry. E is equal to 1 by 4 pi epsilon naught into Q by R square, where Q stands for the source charge. When the Q is halved, obviously the electric field will also get halved. It's very simple. So let's go to the next question. The force exerted by the uniform electric field On an electron having mass me and proton of mass mp are represented as Fe and Fp. The force exerted by a uniform electric field on an electron or a proton. And they're talking about a relation. And E is equal to F by Q, F is equal to E into Q. The force on the charge Q due to the electric field is F is equal to Q into E. And the charge on the a proton and electron is just the same. So then for a given electric field, obviously, just because the mass is changing, the mass of the proton is much greater than the mass of the electron. But doesn't matter, that's not going to affect the force on it. So Fp and Fe are the same. So let's go to, so option number A is right answer. Let's go to 20th question. A positively charged ball hangs from a silk thread. We put a positive test charge Q0 at the point and measure F by Q0. Then it can be predicted that the electric field strength E is, what is this question? Let me understand this. Yeah, I understood the question. You have a positively charged ball hanging from a silk thread. Now we put a positive test charge Q0 at a point. So what is electric field strength? How you bring a unit positive test charge from infinity to point in the region of the electric field produced by source charge. So bring it like that. So you know that F by Q0 will be your electric field strength as per your experiment. But having said that, the moment you bring this positive charge near it, there's a redistribution of charge which is happening in the positively charged big ball. Okay, where there is less charge in the front half surface. The near end has got lesser charges and more charges the back surface because you're bringing in a positive charge here. The positive charge, the charges, both of them are positive, so it's going to get repelled, the charges within itself. And so what happens is, since there's a redistribution of charges, the net electric field, the net force will decrease because the net charge between them is decreasing. And so the net force is going to decrease. Because of this, the net electric field calculated value will also decrease. So, but therefore, the calculated F by Q0, the actual electric field will definitely be greater than the calculated F by Q0. So then there is not so much accuracy as you know. So then therefore, what can you say? The existing electric field will be greater than F by Q0. The existing electric field. The question is not clear, but just this is not an important question, but for you to know. I'm sure you could not have written this correctly. So it's okay if you have not written, but just get to know it. 21st question. In the diagram given below, can you see it's a non-uniform electric field? Yeah. The areas of P and Q are equal, but more lines are passing through the P than the Q. So the field is more stronger at P as compared to Q. Obviously, closer the lines, electric field is more. And the flux is nothing but number of field lines crossing area, unit area, and therefore P is stronger. And so 21st question, which is this point P is stronger? Field lines at P, the field is more at P, more strong at P and less at Q. So then can we say C is the right answer? So let's go to 22nd question. Two unlike charges of same magnitude Q are placed at distance d. The intensity of the electric field at the center of the line joining the two charges. Two unlike charges, opposite, plus Q and minus Q, placed at distance d. The intensity of the electric field at the center of the line joining the two charges. Nowhere between a positive and electric field, positive and negative charge can the electric field be 0. So then there at the center you will definitely have an electric field's value, correct? So that's the electric field's value you have to calculate. You have to mark the directions, and as you should consider at the midpoint, so d and d by 2 and d by 2 is the two distances. So then you know how to calculate it. It's 1 by 4 pi epsilon q by d by 2 the whole square. Another is minus q because it's oppositely charged. Though this here they are not writing it the way we have to write. We'll put 1 as plus q. And the other also is plus q once you draw the direction. Yes, once you draw the directions, yes, at the center, it will be opposite directions. So it's okay to write plus q and plus q, I'm sorry. And equating both of them. Oh, you can't equate, it's not getting cancelled. It's between positive and negative, nowhere it will be 0, so you have to add both of them. and you get this as the answer. And which is 8q by d square. So B is the right answer. So 23rd question. 2 point charges, 2 plus 8 coulomb and minus 2 coulomb are located x is equal to 0 and x is equal to L. The location of the point on the x-axis at which the net electric field due to these two charges is 0. Between positive and negative, definitely it will not be 0, the electric field. So where it will be 0 is beyond minus 2. I've told you lesser charge. So then you have to, beyond minus 2, you have to mark a point P and can call it as x. We'll normally call that as x, okay, but here since it's given L to be the distance between the origin and the minus 2q, that is 8q and minus 2q. So they're calling this a small l instead of x. Okay, and you know that that's the point at which electric field will be 0. You resolve it as vectors and then equate it and get a relationship. So then answer has to be 2L, 23rd sum. 24th question. There are figures given, regular hexagon with charges at the vertices. In which of the cases the electric field at the center will be 0? It has to have all positive charges or all with a negative charge. That's the only case when the electric field at the center will be 0. So obviously option number A is right answer. Okay, so let's, or else it can be mixed with positives and negatives, but it has to cancel out, you have to verify it. Okay, so then next sum number 25. A charged particle is free to move in an electric field. It will travel, okay, you know the path taken by unit positive charge is the line of force. 25th, the electric field E points along the tangent to the lines of force. If the initial velocity is 0, then due to the force it moves in the direction of electric field. You know the charged particle when placed in electric field, a unit positive charge when placed in an electric field moves along the electric field path. That's what is called electric field line. But some other explanations have been given. Let me read it. Yeah, I understood. This option number B is the right answer. See, the charged particle when placed in an electric field, unit positive charge placed in an electric field takes one particular path. That's known as electric field line, correct? So then the initial velocity of this particle has to be 0. Then obviously it will travel along the line of force, or it will travel along the direction of the electric field. Okay, so then the option number B is the right answer. So next question, 25th is over. 26th question. Which of the following is not a property of electric field line? Electric field line does